So for the second question, we're asked to simplify four different expressions that involve exponents. Some of them are negative, and some of them use things such as powers to powers or product of powers or quotients of powers. And knowing those rules, having them memorized is convenient, of course, as long as they're not being misapplied and we're not overgeneralizing. When we look at I'm going to zoom in because I don't need those answer blanks. When I look at part A, I look at this expression. The thing that I'm drawn to is, first of all, I definitely have powers of y in my answer. And if you look at it, this first part has 7 factors of y. Literally y, 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 y. There's 7 of them. And this has 3 factors of y. So I know in my answer, I'm definitely going to have 10 factors of y, right? And again, we could write these all out, use the definition of exponents, exponentiation, and see that. But at this point, I know 7 factors of y and 3 more factors of y is a total of 10 factors of y. Again, this word factors, I keep using it. Factors are those things that are used to create a product. So when I say factors of y, I literally mean these are factors of y, and I have a total of 10 of those, right? So it's all multiplication there. The next thing that I have is I have these factors of x. And if we know the rule, right, we can immediately just go ahead and write down, oh, that's 5 of them, and then 2 of them are apparently down in they're negative factors of x. So those would be down in the denominator. I could simplify, or just simply 5 minus 2 is 3. So I could write x to the third. But it's nice while we're here just to kind of review the whole negative exponents and what that looks like. So if I have x to the fifth, and then I'm multiplying that by x squared, to the negative second rather, I could use this tool that we've discussed in class several times. I could neutralize the negative exponents by multiplying by x to the second and then x to the second. I know that this is x to the 0 power, which is 1. And you can see this becomes x to the fifth over x squared. And literally there are 5 factors of x in my numerator, and there are 2 factors of x in the denominator, and you can see this giant 1. But the bottom line of the story is definitely there are 3 factors of x. This is x to the third, and that's probably overkill. The next problem, you can see we have 3 factors of exactly this thing. So to process those, I might go ahead and think of this as a 2x squared, and I've got another one of them and another one of them. So there's a total of 3 things that look just like that 2x squared, 2x squared, 2x squared. Now, as I'm looking at my factors of x, I quickly identify the fact that there are 6 of them. I have exactly 6 factors of x. The other thing that I see is I have 2 times a 2 times a 2, which ends up being the number 8. Another way you might think about this, when you raise powers to a power, we can use that multiplication shortcut. So if I'm looking at this, I could look at this as 2 to the first times x squared, and I'm raising this to the third power, and what I can do is I can say, look, this is going to become a 2 times 1, or 2 to the 1 times 3 power, and then I'm going to multiply that times x squared times 3. So when I look at these individual products, right, 1 times 3 is 3, 2 to the third is the number 8, and 2 times 3 is exactly 6. So we end up seeing that we do end up indeed getting 8x squared. The next problem is, I think, perfect for thinking about in terms of a giant 1. This number 10 is 2 times 5. And I actually, for convenience, I'm going to write it as 5 times 2. And the denominator 4 is a 2 times a 2. And I think you'll see where I'm going with this in just a second. In my numerator, I've got 12 factors of x. I'm going to choose to rearrange those. I'm going to write it as 7 of them times 7, 8, 9, 10, 11, 12, 5 more of them. So x to the 5th power. And then down below my denominator, you can see I've got 7 factors of x. Now, the reason why I broke the 10 and the 4 and the x to the 12th up this way is I can clearly identify the giant one. Both of those have factors of 2, and they both have 7 factors of x. So there's a giant one of 2x to the 7th over 2x to the 7th. And when I simplify this expression, I get 5x to the 5th power, and that's all divided by the number 2. And it's fine if you wrote 2.5 x to the 5th, but I think either 5 halves x to the 5th or 5x to the 5th over 2 is probably a preferred answer. And then finally, you can see we have some negative exponents here, and a lot of incorrect things were done with this problem. I'm going to use the tool that I keep going back to. I'm neutralizing the negative exponent. In my denominator, I now have x to the 0 power. In my numerator, I have 5 times x to the 6th power. You can see there's 4 factors of x and 2 more factors of x. That's a total of 6 factors of x. And of course, x to the 0 down in my denominator just equals the number 1. So this is all over 1, so I can just write 5 times x to the 6th power. So I hope you found those helpful.